Let's get a precise understanding of what these brackets and parentheses mean when we want to describe the behavior of a graph one interval at a time. So we have two kinds of parentheses we use for interval notation. The squared off brackets indicate a closed interval where the endpoints are included. The rounded parentheses indicate an open interval where the endpoints are not included. For example, if we just look at a number line and we have solutions that start at -3 and then continue in this direction, we could describe that interval with a closed bracket on the left end of the interval because -3 is included. And then we show the right side. Well, the right side in this case doesn't exist because it goes to infinity. There is no end point. So we put positive infinity, but we use the round parenthesis to show that there is no exact endpoint that's included. Let's try another example. If we have an interval that goes from 1 to, let's say, 7, where neither endpoint is included, to describe this interval, we would use rounded parentheses for the endpoints to show that 1 and 7 are not included, but the interval is all values between 1 and 7. Let's try some examples on the coordinate plane. Here's a quadratic equation in vertex form. So we can see right away that the vertex is at +2, +3. And it's a parabola, so let's graph this. There's our vertex. The coefficient is 1, so I know it's going to go upward. Let's plug in 0 and see what happens. When x is 0, I get 4 + 3 is 7. So I have a y-intercept at 7, which means there must be a point over here as well. And our graph looks something like this. Okay, if we were to describe the domain and range using interval notation, it looks something like this. The domain is equal to, and then we describe the x values. What interval includes all the x values for this graph? Well, even though it's moving to the left slowly because it's a steep graph, it is eventually going to use all values to the left. So it starts with -infinity. The same is true for the right arm of this equation. It's going to go all the way to infinity. So that's the domain. The range would be everything including y equals 3 and then above that. So we're going to use the square bracket for the end point at the vertex, and then from there it goes up to infinity. So we would use a rounded parenthesis, and you can see how we can mix those up to show what we need. Let's find the domain and range of this function. Well, we know because the denominator that x cannot be equal to 4, so we have a vertical asymptote at 4. And y can't be 0 because there's no way to make this fraction equal to 0. So we have a horizontal asymptote at y equals 0. Let's draw those in. Okay, there's our asymptotes. Let's add the curve. It goes something like this. So for the domain, it starts at -infinity and then approaches +4 without touching it. We're going to use set notation to combine that with the other interval, which starts right after 4 and goes all the way to +infinity. The U is for union, which combines these two intervals into one answer. The range is very similar. It also starts at -infinity and approaches 0, and then starts on the other side of 0 and goes to +infinity. And so there is the domain and range using interval notation. Here we have a V-graph with a vertex at -1, -4, and a coefficient of 3. So let's graph that. There's our vertex, and using the 3, we can get a few points on the right and on the left. All right, For the purposes of describing increasing and decreasing intervals, we use the x values. So let's identify the x value intervals where the function is increasing or decreasing. The right arm of the v is the increasing interval. It starts at the x value of the vertex, which is -1, and goes to infinity. Now, where is it decreasing? You need to consider the graph as it moves from left to right on the x-axis. So it's decreasing on the left arm, starting at -infinity and going to the vertex. The x value is -1. And that should get you started. You're ready for homework.